Well, looky what just showed up in the mail. I guess not the mail, but FedEx. An HP 5334B frequency counter. I bought this unit off eBay for a really good price, so I hope there's nothing wrong with it. The buyer did show it powered on, but he said that he was having some problems with it. It was showing an error number 2, when he was attempting to enter a time base, and that particular error is a user error. So he may have just not been selecting the right time base for some reason. And but it's in very nice condition. I did put some feet on it because it didn't have feet when I got it, but it's somewhere in the back here. Everything's there. It has the high stability time base and the 1.3 gigahertz option. So I think I will power this thing up and let's see what it does. I mean, I paid under $100 for this, shipped. So it was too good of a bargain to pass up, because I've got another one up there. Like, I needed another one of these, like I needed a hole in the head. But these are actually very nice frequency counters. So I'm a glutton for punishment, and so I bought it. And let's see what happens. Well, after leaving it on, or plugging it in and letting it idle for, I don't know, well over 12 hours, I think I'm ready to test it. I didn't want to power it up initially because I wanted the oven to get up to temperature, but we've added a couple things here. We added the GPIB cable so I can test it remotely. I had to put this switch over to internal because it was sitting over here on external, so maybe when it was in a rack it was using an external reference. But it does have the high stability option installed and the C channel installed, which is indicated also by this option here. This option here, H05 or H05, is basically these two options combined. So, and this counter was, come on, focus, is based on a 1988 design. It was the 26th week of 1988, made in the U.S., and it was the 1,788th unit produced. So, fairly new. Well, I guess it's relative. But, come on, get there. Like I said, it's in really nice condition. It's in better physical condition than my other counter. My other counter was made a year later, so it happens to be a newer unit. This one's just a year older. But it's powered on here. I'm going to do some basic tests. I'm going to use this HP 5359A time synthesizer to measure pulse widths, and we'll use the signal generator there to test the limits of the counter, make sure that all the 3 channels are working, and so on. So let's get to it. Alrighty, so here we go. Let's power it on. See what happens. Address 3, pass. Wow, jeez. Okay, so let's take the cable here from the GPS DO, and we'll slide this over a little bit. Okay, let's check channel 1. And boy, what do you know? Looks like the oscillator's running a little slow. Showing about 100 millihertz. Counter's showing 100 millihertz high, which means the oscillator's running slow. Let's turn the 50 ohm terminator on. Yeah, so far so good. Okay. Let's try channel 2. Same thing there, and turn the terminator on and move to B. Hey. It's working right on. That suits me just fine. Okay, let's switch over to Take this off here. Just bear with me here. Alright, we'll hook it up to the signal generator, and we'll start at 10 megahertz, 0 dB. It's showing the same. It's good. So let's go back over to here. Go back to frequency A, or channel A, excuse me. All right, let's take it up to 100 megahertz. And what do you know? There's 100 megahertz. Still showing a little high, but that's because of the internal time base. Okay. Let's go over to, come on, get on there. Oh, it's already on there. Okay, never mind. I'll be damned. Looks like it's working. All right, well, let's try the third channel here. And that's working too. Okay, well, since we're on the third channel, let's go to 500 megahertz. Yeah, working just fine there. Okay, let's go to 1300 megahertz. Doing fine there. Okay, let's see if this thing will exceed its spec. Let's go to 2 gigahertz. And what do you know? Okay. So yeah, this seems to be working at least in those regards. So let's do a pulse width measurement and see what happens. Alrighty, we got our pulse width set for 100 nanoseconds. Pulse train frequency is 1 megahertz, so that's about as close to 1 megahertz as this thing's going to show. So let's go to pulse width. Wow. It's like plus or minus 1 nanosecond. I would say that that functionality is working just fine. Interesting. Well, I would say that they're that other than the reference oscillator being off a slight a bit, I would say this counter is doing just fine. Now I can get into more detailed measurements, but so far this thing is looking like it's doing just fine. All of a bargain for under $100, so I would, if you're looking for a good counter, you know, I highly recommend these counters. They're very durable. They're very capable counters. I bought one of these a while back originally to replace an HP 5328A that I had for like some 20 years. I think I mentioned this in another video or something, but it died of a power supply failure, and I bought one of these to replace it because I wanted something with a little more capabilities, wanted something with a bit more capability in regards to GPIB. So, yeah, not bad. All right, well, let's keep going here. Alrighty, man. Let's move on to the next thing here. Let's try issuing some commands to see if the GPIB is working. So right now it's on function 1, which is channel A input, frequency for channel A. Let's try let's try going to the totalizer, which is function 8, or no, function 9. So give me a second here. All right, let's finally see if we can change the functions remotely. So I'll bring up my National Instruments instrument control software, and let's put function, what was it? Function what? Function 9. So we'll go function 9. And we will write to the instrument. And there we go. That's totalizing. So everything works. Interesting. That is cool. What the hell of a bargain. It's okay. So let's try switching to another function. Let's try going to pulse width, which is function 10. So we'll go over here and change that to 10. Right. Yep, there we go. That's what we're supposed to see, so damn. Well, folks, I guess that's going to be it. Maybe later on I'll do a more in-depth tutorial on this. But these are really nice counters. This is now my second one. They have a very nice set of commands that can be used remotely. The software is, you can download the software right off National Instruments website. You can also, their drivers actually for their GPIB cards, which is what I prefer to use. And you can get it for Windows or Linux. Linux is a little more difficult to do because you got to download the repositories and install them on your Linux distribution of choice. But they do offer pretty much all the same control software applications that get installed under Windows. But I also use Python and use a number of scripts to send commands to my instruments here to set them up for certain test settings. So, but good deal. I'm glad this thing works. So for that, I guess this will be it for now. So thanks for watching, and guys have a good day. See you around.